Thank you, Jeff. Good afternoon. Yes, my name is Francis Butler from University College Dublin. And yes, I think the overall, theme of my presentation will focus on the global food chain. And essentially what we have here, we have, and it was interesting, we just had from the previous speaker a discussion on pizza, but to reflect a little bit on pizza and the fact and our expectation that this person delivering a pizza to our door, the expectation and our experience is that that person will deliver a product that is safe. But yet behind that simple pizza, in a product in one box, when you start to look at the number of products, the number of individual ingredients, you have a whole complex global chain there, well over, so many products, over 50 products, when you count them up, coming truly globally. So the wheat might come from Canada, the tomatoes may come from Italy, the soya that may come from Brazil, all culminating in a product that we expect, and our experience is that it's safe. And also I think it's a little bit sobering to dwell on the fact that this is a product that is delivered for some euros, depending on the country, but it could be 3-4 euros for this one product. But yet behind that there is this vast complex web which is the global food chain, which combine together to give you this safe food product. I suppose specifically what my presentation is, I want to showcase two outcomes from the traceability projects, EU-funded traceability projects, where we delivered new conceptual protocols. So we have seen over the course of today, I suppose, quite a lot of showcasing of various technologies, various new method development for pathogen detection, new DNA technology for guaranteeing the origin of the foods. Specifically what I want to talk about in this, when we start to think about the food chain and the global food chain and its complexity, is two specific projects that delivered conceptual protocols. First of all, to identify food chain vulnerabilities. It was a project that I was responsible for as coordinator, where we developed essentially a new protocol for systematically identifying and addressing vulnerabilities in the food chain. So I will say a few words about this project. And then my colleague Gary Barker will talk about biotracing in the food chain, which is essentially, so the first project is essentially a preemptive approach. Biotracing by its nature is a little bit more a forensic approach, a modern day Sherlock Holmes approach, whereby we have an event, we have some sort of contamination event, and then Sherlock Holmes type, we can start to look systematically, given the information we have available to us, how can we work backwards and possibly apportion the outcomes? Where can maybe that traceability come into the food chain? So essentially we'll have two short presentations, and I will talk specifically then about the project that I was responsible for, which was addressing food chain vulnerability. Moving to that project, and specifically again, and I think this theme has come up several times over the course of the day, the complexity of the food chain. We actually use the word food chain, but in fact it's probably a misnomer. It's probably the wrong word to actually use for food chain vulnerability. It's more like a maze, it's more like a web. It's complex, and it's dynamic. And these are some of the issues that we address in this project. First of all, the complexity of the project, but also the fact that it's dynamic. That, as knowing for several reasons, processors will change ingredients, will change suppliers, possibly based on availability, possibly based on price, and all of those issues then conspire to change essentially what is the chain that you are looking at. So I think it is very important to stress that it is not just food chain. We had Mairead McGuinness this morning, MEP, talking about our own youth and our own very simple food chain. Essentially straight from farm directly to neighbour consumption, a very short food chain. But if we start to think a little bit about the pizza example, we have in reality for many processed foods very complex global chains. And let's not forget about the feed chain. And just what I have there, legacy of the Irish dioxin pork crisis in 2008, a small little experiment you can all try at home. Just type Irish pork into Google, I suppose as an Irish citizen, I would like to think that you get a positive response for that, knowing things like quality, knowing green issues. But in fact, when you type such a thing, these are the type of hits that you get. That Google will bring you back to, to that instant, fairly serious global incident we had in 2008, and all of the images that will come up through Google then are empty shells. Even stories going right over to China, reporting on these issues. So really, the take-home message in relation to global chains, they are complex, and we should not forget about the feed chain as well, and that is very important. And these were some of the very important, difficult issues that we had to address then within our project that looked at vulnerability. Specifically then, moving to what we attempted to do in that project, and hopefully that what we delivered in terms of that project, was a new framework to systematically assess chain vulnerabilities. And I use the word, I suppose not lightly, the word systematically, that we have a process in place to look at, for your particular product, wearing either the perspective of a regulatory authority, wearing the perspective of a processor, how can we look systematically what might go wrong here? Where are the vulnerabilities in the chain that we have to deal with? And really our starting point is the chain. We have to, and the example I've given there, possibly not that easy to read, is to work down, conceptually it's not that difficult, but it's to work down from what may be present in it, what contaminants might be there, how can we potentially rank those products, and ultimately then how can we control those products. And really, at the core of this, in terms of methodology development, was to develop a robust risk ranking methodology. It's not rocket science by any means, but we need to put in a risk ranking methodology that was hopefully objective as against a lot of the subjective ranking techniques that we typically use, particularly in relation to things like HACCP. And essentially what we need is a scoring system, and we need a scoring system which, particularly for chemical contaminants, for a lot of biological contaminants, if you think of, let's say, a yogurt product, for instance, it's relatively easy to identify, the biological contaminants that are there and possibly to rank those, but to start to think conceptually what chemical contaminants might be in a dairy product, for instance, very quickly the number of potential contaminants can go into the hundreds. So we need to think, that is our starting point, what potentially can be there. Then can we move to actually to rank them? And really, typically, the robust, relatively straightforward mechanism we used was a ranking protocol based partly on severity, what will be the outcome if the contaminant is present, and also based on likelihood, what is the chances of occurrence of this contaminant. And in a sense, and maybe it's interesting as we work through this project, and an appeal particularly to the people who may influence that, but because it is an objective process, it is very much based on data, and in many cases data that is hopefully out there in the public domain. And it was certainly one of the bottlenecks that we saw in carrying out this project, that when we go to look for objective evidence, for instance of contamination, let's say of dioxin, there's a massive amount of data potentially out there, but to actually go out and access that information, again wearing either a regulatory authority hat, an individual company's hat, to actually go and get that type of information, because that is the information that will underpin these type of risk ranking methodologies. And I suppose an appeal, having worked through this project, and particularly for those in the audience, there's people here from the regulatory authorities, people here from the Commission, people here from parliamentarians. We need to think collectively right across the European Union. If you look at all of the individual member states there, we probably calculate, I saw the figure once, certainly it's well into the millions, the number of individual tests that we carry out within the European Union every year in relation to contaminants in the food chain. I think there's a challenge there to bring that information together, to view that information as a resource that we can use precisely for these type of techniques and other risk assessment techniques to objectively, and again I use the word objectively as against subjectively, rank the pathogens, the contaminants that may be present in our foodstuffs. And really we moved from that. Within the project we moved from risk ranking, typically based on severity likelihood, but we then recognised that there may be other additional axes that might influence that that decision, knowing where exactly is the vulnerability, and issues, for instance, the example I give there is the ease of detectability, for instance. So, as a simple example, much simpler to detect something like an antibiotic in a dairy product, because the cost of the test is relatively cheap, readily easily to do. Now, in contrast, maybe to test for dioxin in the same product, where the cost now is several €100 per sample to be analysed, and it's complex, and the availability of the equipment is limited. So we need to think, when we started to look at actually identifying the vulnerabilities, we also had to think not only of likelihood, severity, but issues like how easy is it to actually detect this in the product under interest. So I suppose in conclusion, Chair, just I suppose from the outcome of our side, in a sense we delivered what we were asked from the Commission. We delivered an approach, a structured approach to delivering, assessing vulnerabilities in the food chain. We delivered it both in a text-based and in a web-based version to actually address, how do we go about a step-by-step guideline to how we do that. But I think the challenge, and again this has been a recurring theme over the course of the day, I think, just listening to the various presentations, is the, we heard it this morning in terms of translation research, how we go back, how we push this out into general use. And I think, certainly specifically in this case, we have a bottleneck there, that to really push this out, for large organisations, I think they have access to the information, but if we bring it down to the SME level in particular, I think we have issues there about availability of data to these type of organisations, these type of companies, that they can carry out the type of vulnerability assessment that's set out in this guide here. Copies are available actually outside when we get a break at the end of the formal presentations. I'm going to stop there. I'm going to ask my colleague Gary Parker then to talk a little bit then on the biotracer approach, which again is another example of a systematic, a structured, conceptual approach to how we address pathogens, how we address contaminants in the food chain.